So chapter 3 has been unfortunate in that it's almost entirely word problems. Some of these are much different levels. Some of them were real simple where we're plugging into the area of a triangle, and others have been real complicated. So we've got one last section of more complicated ones. We have distance equals rate times time again on these. But they're going to add one little twist. So let's get started. What they're saying in here is we need, if these rates are in miles per hour, then we need our time has to be in hours as well. If we tried to multiply miles per hour, so you're going 50 miles an hour and you were doing it for 30 minutes, if you multiply that by 30, you've got a number that doesn't make any sense at all. What you have to do is convert that so that you have it has to be in hours. Since you're miles per hour, you have to make these match. You got to make hours match, or else you're going to get the wrong answer. So let's start here. Here's the story. Let me start building our chart here. So somebody walks to school and sometimes she rides. And so we have her rate, time, and her distance. So we saw in the last one, rate times time equals distance. Now we're going to go and fill this chart in. So, well, first of all, so let's start. We know that my I don't know is how fast she's walking. We don't know how fast she can walk it, but we know when she rides her bike, it's 3 miles an hour faster. Now, here's where the issue comes in with the time. It takes her 30 minutes to walk, but our rates are in miles per hour. So I have to turn 30 minutes into hours. Isn't that a half an hour? 30 minutes is half an hour. And then lastly, her time on her bike, it's 15 minutes, but we need this to not be in minutes. It has to be in hours. So that's 0.25 hours. Okay, so now we're going to fill in our distance column just by multiplying across like we did in the last video. And I'm running out of some space here. Now, she has gone the same distance each time. So I'm looking at the distance column and I need to make an equation. Well, she's traveling the same distance each way, so I can do 0.5x equals 0.25 x plus 3. So this is pretty similar to what we did before. The only thing that changed here is I have to set up the times so that they're in hours, and they were given in minutes, so I got to convert that. Okay, now they did them as fractions, which would have been fine, but I made them decimals and solved just like we've done before. So we wind up getting 3 miles an hour for her walking speed, and then we put it back in the dictionary. 3 plus another 3 was her biking speed. Okay. So somebody hikes uphill and they hike downhill. Rate times time equals distance. Okay, so we don't know her rate going uphill, but they tell us downhill is 1.2 miles per hour faster. So it's in miles per hour. Okay. So let's see, back down. So it's 30 minutes. So 0.5 to go down the hill. It takes her 50 minutes to go up. So I'm going to turn this 50 minutes. There's 60 minutes in an hour. So I'm going to turn this into a decimal. I'm going to find out what percentage this. So it took her 5/6 of an hour. But I'm going to do all of mine as decimals. So I'm going to divide that. So again, it took 50 minutes, but there's 60 minutes in an hour. So if I divide these here, I now have how many hours it took her. And I get an unpleasant fraction. What to do here? I'm going to leave it then as 5/6. Okay, so I'm going to turn this back into a fraction just because that one didn't work very well. Sorry, so 5/6. Let me go back through this again because I'm making this confusing. Uphill, we don't know how fast she's going. Downhill, she's 1.2 miles an hour faster. So we need our units to match. Now it was 30 minutes to go downhill. I've turned that into 30 minutes over 60 minutes to make this a fraction. So that's a half an hour, 1/2. Now the problem was 50 doesn't work out nicely, so I put 50 over 60 to see what percent part of an hour it took her to come uphill. Now I reduced that by dividing, cut off the zeros off both of them, but they both could be reduced by 10. So uphill took 5/6 of an hour. Now let's multiply and make our distance 5, 6x. I've got 1/2 times x plus 1.2. Now she traveled the same distance, so we're looking at the distance column now, and we've got 5/6 x equals 1/2 x plus 1.2. Okay, now I'm going to go ahead, I don't do this very much, but I'm going to multiply both sides by 6. Do you remember our trick? If I multiply by the fractions, I look at 6 and 2, and they could both turn into 6. Okay, now if I multiply that 6 on both sides, that will get rid of all the fractions. So I'm going to do that by every group. So this makes 5x over there. Now, do you remember this discussion? This entire thing, because it's multiplication and the addition is on the inside, this is all just one big group over here. So all I need to do is multiply the 6 by the 1/2. And when I do, I get a 3. So it's done that entire group because it's out front there. So I multiplied both sides by 6 to clear out these fractions. Okay, now we're ready to just start cleaning up. Got to distribute. I get this. Now the rooms are clean, but I have idle nose in both rooms, so I'm going to get him back together. So I'm going to have 2x equals 3.6. Divide both sides by 2. X is going to turn out to be 1.8 miles per hour uphill. That's what x was. And downhill is 1.8 plus another 1.2. I'm just sticking it in here. I didn't make my full dictionary. Maybe I should. So uphill is 1.8. Downhill is 3. Okay, this guy or gal, I don't know who that is. His, so I guess it's a guy. And we have up and down stream. Okay. Okay, so downhill. So we don't know his speed going uphill, or upstream, I should say. But downstream, he's 4 miles per hour faster. Okay, now I don't need to do fractions this time because I've got nice 45 minutes and 30 minutes. So downstream took him a half an hour. So I've made this in hours because I need the units to match. Do you agree that 45 must be 3/4 of an hour? So if you're unsure about that, what I'm doing is 45 divided by 60 minutes in an hour, and that turns out to be 0.75. And I'm doing 30 minutes, and there's 60 minutes an hour, that's 0.5. So I'm going to multiply across because I always want that distance column filled in. Okay, now did he go the same distance? Yeah, so he goes down and then he goes up. Okay, so he's gone the same distance. So I can set these two equal to each other. Now I could clear out the decimals, but I don't usually do decimals. I clear out a fraction, but usually not the decimals. I'll just work this with the decimal. I'm sure that's 2, but I don't feel that confident with decimals. Yep, it is, so I get the 2. Okay, so the rooms are clean, but I've got idle nose in both rooms. So we're going to take care of that by getting him back together. I'm going to take him out of the one room, so we got to take him out of the other side too. Okay, divide both sides by 0.25 to get him alone. And I get 8. Now, that was the speed going uphill. So right here. Now downhill is 8 plus 4, or 12. So all of these, we just had to match the time so that it was in hours. Okay, if I remember right, this is getting real complicated. Yeah, this one's real complicated. So let's go through this. And I don't think they have the, no, they didn't do it. So, all right, this guy's driving first in the city, and then he's driving in the desert. So let's do rate times time equals distance. Okay, so here's what's different. We don't know how fast he's going in the city. So that's his city speed. We don't know what it is. It's I don't know. And what's different about this one is it's not, we don't just add 1.75. He's 1.75 times faster when he gets out of town. Well, that's multiplication. 1.75 times faster than the city speed. So we've never seen this before. We have the city speed, and then he's driving 1.75 times faster. That's multiplication. And then they've even kind of hidden the times a little bit. How long was he driving in the city? Well, 2 hours, from 2 o'clock to 4 o'clock. Now, how long was he driving in the desert? That's 2.5 hours. Now, everything was fine here in the units. We're in hours, and so everything matches up. Now, let's fill in the distance column. And we get this. And then we know this, that he traveled 250. So we're worried about the distance column to make our formula. It would be this. We're adding up those two distances he traveled, the two different parts of the day, and we know that he covered 255 miles, so we just add them. Okay, so we've got some multiplication to do here. I've got 2.5 times 1.75. So plus 4.375x. We get, sorry, I'm coming up here, I'm running out of space. I just combined like terms down here. That's all I did, just put those together. Now, I'm going to divide both sides by 6.375. I know it's a weird number, but the principle's the same. To get rid of him, to get rid of a factor puzzle, I just divide it away. I'm crunching this on my calculator. Oh, it worked out nicely. So x turns out to be 40. Now that was his city speed, and if it wants both, it does. So 1.75 times 40 must have been his desert speed, and that turns out to be 70. So 40 miles per hour in the city, 70 when he hit the desert. Okay, we got two of these to work. Let me work another one, and then I really recommend you pause and try the one at the end. Okay, so he's biking, and sometimes he's running. Okay, so we don't know his running speed. When he bikes, it's 1.6 times faster. Do you see what I've done there? Okay. Now, he ran for an hour and a half, and he biked for now do you see what I've done here? So he biked from 7:30 to 9:45. That is 2 hours and 15 minutes. So 15 minutes has to be in hours. 15 minutes is 0.25 hours. Do you see what I've done? So 2 hours and 15 minutes is 2.25. Now we do our distance column. I'm going to do this in a little different order just so it is more algebraic. Okay. So when he did these two things, so I've got the distance column finished. What are we doing with it? He did this to cover a distance of 51 miles. So he did them each, and they totaled. So he added them up. That's a 6. 51. Okay, so let's do some cleaning up here. This room is all messy. We got to clean it. I'm multiplying the 2.25 times 1.6. Okay, so far I get this. Now let's combine like terms here. Now, even though it's a decimal, dividing it works exactly the same. And so x is 10. Now that's 10 miles per hour. And I didn't do my dictionary. This was just, we can go back here and do it too. That was running speed. And his biking speed is 1.6 times that 10. Well, that must have been 16 miles per hour. So he bikes at 16 miles per hour and he runs at 10. Okay, one more of these. These are hard, so I'd recommend you pause the video. So he's going on flat, and sometimes he's going uphill. My rate, time, and distance. Okay. Got confused by that, but he's going to be slower going uphill, which would mean 0.6 times x. That would slow him down. Now let's figure out his time. So he went an hour and 15 minutes on the flat ground. Remember, what I'm doing with 15 minutes is I'm dividing it by a whole hour, and that's the 0.25. So an hour and 25 from 10 to 11:15. Then he rode uphill until 11:45. So he spent 30 minutes going uphill, which is half an hour. Okay, so we always want to make the distance column. Okay, and they told us, so they're telling us a total of 31. So he did one thing and then he did the other, so we're adding this. That's a 1 there, sorry. Okay, so I got 0.5 times 0.6, just cleaning up here, and I get 0.3x. So that was point, if you can't see that. So I put these together, I get 1.55x equals 31. Now I'm dividing both sides by 1.55. Nothing changes just because it's a decimal. So I get x is 20. So he's going 20 miles an hour on the flat ground, and uphill he slowed down. So I'm going to multiply that by 0.6 and see what we get. And when he was going uphill, he's going 12 miles per hour. Okay, that's the most difficult thing we've done so far. The big key is just make sure that you are, if your rate is in miles per hour, our times need to match. And then the other twist they had is that sometimes they were multiplying the second rate as opposed to normally we would just add something onto it.